Picture this: NASA scientists preparing a spacecraft for Mars, the cleanest labs on Earth. White suits, sterile tools. Not a germ in sight, or so they thought. Then suddenly, 26 unknown bacteria appear. Not in soil, not in space, but inside the clean room itself. This isn't science fiction. It's happening right now. NASA just uncovered extremophile microbes in one of their most sterilized spaces. And some scientists believe these bacteria might just survive the harsh surface of Mars. Welcome to Strange But True Facts, where reality is weirder than fiction. Let's get into it. Before any Mars-bound spacecraft leaves Earth, it must pass through a fortress of sterilization, known as a NASA cleanroom. These are ultra-controlled environments. The air is filtered 50 to 100 times per hour. Humidity and temperature are perfectly regulated. People wear full-body suits, no hair, no skin flakes, no bacteria. Why all this fuss? Because of planetary protection protocols. NASA and other space agencies must avoid forward contamination, the accidental delivery of Earth life to other planets, especially Mars. If we're searching for signs of Martian life, we must be absolutely sure it's not our own microbes hitching a ride. And yet, that's exactly what might be happening. In a recent study led by NASA's Jet Propulsion Laboratory, JPL, scientists swabbed surfaces inside these sterile cleanrooms: walls, equipment, tools, ventilation ducts. What they found was shocking. 26 previously unknown bacterial species and strains, completely new to science. These were not just any microbes. They were extremophiles, hardy organisms capable of surviving where most life dies. Some of them could withstand high radiation toxic cleaning agents, extremely low nutrients, and even near-total dryness. Let that sink in. These organisms were living and thriving in one of the harshest artificial environments on Earth. So, what does that mean for space exploration? To the average person, bacteria might seem boring. But these tiny creatures are evolutionary marvels. The strains found in NASA's labs belonged to genera like Tepidiphyllus, Penobacillus, and Acinetobacter, some of which have been linked to radiation resistance and extreme desiccation tolerance. One species even showed potential resistance to peroxide, an agent commonly used to sanitize spacecraft components. In simple terms, these microbes are built to survive space-like conditions. Some experts believe if these bacteria made it to Mars, they might actually survive the UV radiation and thin, dry atmosphere, at least temporarily. And that's a serious concern. If Earth microbes survive on Mars, several things could go wrong. False positives. Future missions could detect signs of life, only to realize it was life we accidentally brought there. Ecological interference. If Mars has dormant or fragile native ecosystems, our bacteria could disrupt or even destroy them. Ethical concerns. Should we really be seeding other planets with life, even by accident, before we understand what's already there? It also affects plans for sample return missions. If Earth-based microbes hitch a ride to Mars, then come back in collected rock samples, we may misinterpret findings or contaminate our own world. Space agencies take this seriously. NASA follows international agreements like the Outer Space Treaty, which prohibits harmful contamination of celestial bodies. But with these new findings, some experts believe we're already behind. So, how do you kill the unkillable? That's the next challenge. NASA is now considering next-generation sterilization methods, including plasma cleaning, UVC irradiation, ionizing radiation, extreme chemical cocktails, and even robotic sterilization arms with pinpoint targeting. Some researchers propose redesigning spacecraft entirely, creating bioshields or microbe-proof compartments using new smart materials. Others argue for better microbial surveillance, real-time sensors that can detect bacterial genomes on tools before they're sealed into rockets. It's not just about cleaning harder, it's about cleaning smarter. It's easy to fear these microbes, but here's the twist. They might help us. Microbes that survive radiation and chemical extremes could revolutionize industries on Earth. Imagine enzymes that clean up radioactive waste bacteria or that break down plastics in toxic environments. New antibiotics or medicines derived from extremophile genes. NASA and biotech firms are now sequencing the genomes of these bacteria to uncover their secrets. Who knows? One of these cleanroom hitchhikers might hold the key to a medical or environmental breakthrough. In trying to keep life off Mars, we may have stumbled on life forms that could save